Hello and welcome to chapter 2. And in this chapter, we're going to be addressing exponents and powers, square and square roots, cube and cube roots. This chapter might be divided into multiple parts coming in multiple weeks. So let's see how it goes. So, already in class 7th, you have learned about the powers with positive integers as exponents expressing in natural number or as a product of powers of prime factors, law of exponents, and expressing very large numbers in standard form, that is, like in the powers of 10. But in this chapter, today we will learn about the powers of negative integers as exponents and law of exponents. So we already know that 2 to the power 4 is 2 into 2 into 2 into 2, where 2 is the base and 4 is the exponent. Similarly, if we do 2 to the power n, then we have 2 into 2 into 2, and that is for n times. And using this as the base, let us now understand what 2 to the power actually means. So if we go on to understand minus 2 to the power 4, okay, let's first understand what 2 to the power 4 means. 2 to the power 4 is 2 into 2 into 2 into 2, which is 16. Coming down one step, we have 2 to the power 3, which is 2 to the power 3, that is 2 into 2 into 2, and that is 8. And that is also can be expressed in terms of 16 by 2. So there is 1 2 below. Then again, if we go to 2 to the power 2, that comes out to be 4, and that again can be expressed as 8 by 2. And then moving on, we have 2 to the power 1, that is 2 or 4 by 2, 2 to the power 0, which is 1 or 2 by 2. So if we move on with this pattern and continue it in the negative form, we have 2 to the power minus 1 is 1 divided by 2, and that comes out to be 1 by 2. 2 to the power minus 2 is 1 by 2 divided by 2 again, and that comes out to be 1 by 4. And 2 to the power minus 3 again is 1 divided by 2, 1 divided by 2 square divided by 2, that is 2 into 2 into 2, that is 1 by 8. And again 2 to the power minus 4 again then comes out to be 1 by 16 in the very same fashion. So thus we can say that for any non-zero integer a to the power minus m is equal to 1 by a, where m is a positive integer. And that's how we understand the essence of what a negative power is. So another very interesting thing to incorporate in order to incorporate p by q or any rational number is that if there is any non-zero rational number p by q, then and m is any positive integer, then we can express its negative exponent, that is p by q whole to the power minus m, as 1 by p by q whole to the power m, and then that can already also be written as q by p to the power m, or q to the power m divided by p to the power m. And this is a very useful thing that's going to come very handy in the coming chapters. Let's evaluate a simple example. 3 to the power minus 4. What does it come out to be? So we will first convert it into a positive exponent, that is 1 divided by 3 to the power 4, and then solve it. And this comes out to be 1 by 81. Another very simple example is of that of a rational number. And here we're going to again convert these into a positive exponent. So as we have seen from p by q above, we will flip these two numbers to get a positive exponent and solve accordingly. And this comes out to be 243 divided by 32. So these are very simple examples that we can come across. Let's move on to something more challenging for our taste, and that is the law of exponents. So in the previous class, you've already learned that for any rational number a to the power m into a to the power n is equal to a to the power m plus n, right? But where we have seen that this is possible for m and n when they are positive integer. But does this law hold when it is for negative exponents? Let's observe. Let's take an example of 2 to the power minus 3 into 2 to the power minus 4. We will again convert them into positive exponents by taking the reciprocal and solve again. And we again see that the rule is also possible for negative exponents. So we can say in general that if a is any non-zero rational number and m and n are integers that includes both positive and negative integers, then a to the power m into a to the power n is equal to a to the power m plus n. I hope this is a lot clearer now. Similarly, all other laws of exponent also hold true, which I will enumerate here now. I hope this is a lot clearer now, and please take a note of all these identities as these laws of exponents are true for everyone. Let's simplify. Let's simplify this through the laws of exponents that we have learned till now. So, first we will multiply 2 to the power 4 into 2 to the power minus 3, and then that comes out to be minus 12. We also know that any number a to the power 0 would be 1. So 3 to the power 0 becomes 1. And then we solve again to get 2 to the power minus 12 plus 2. And then finally it comes out to be 2 to the power minus 10. Let's do a more difficult question to understand and apply all these laws of exponents again. So in this example, we're going to take and simplify this expression. So first we have this 3. We will multiply this with both the 3 and 4 to get 2 to the power 3 into 3 into 3 to the power 3 into 4, and then minus 5 by 3, and that goes on. Then we do the prime factorization of 60, which comes out to be 2 into 2 into 3 into 5. and then minus 2 to the power 5 remains the same. Then we move on to comparing these two. So 3 into 3 becomes 9 and 4 into 3 becomes 12. And the minus sign goes out here. Again, the minus sign also goes out here on the bottom as well. So that's how we go. So we have 9 over here, uh, and then 2 and 5 in the below. So we have 9 minus 2 minus 5 from the laws of exponents again. And same we do for 3 and 12, 3 to the power 12 minus 1, that is 3 to the power 1 over here. Then moving on, we do that for 5. So 5 to the power 3 minus 1. And that's how we get 2 to the power 2 into 3 to the power 11 into 5 to the power. So let's simplify this expression again. So first of all, we have 1 by 3, 2 by 3, and we have negative exponents for both of them. So in order to convert the negative exponents to positive exponents, we convert them to 1 by 3, or take the reciprocal of 1 by 3 to 3 by 1 and 2 by 1. So that's how it comes out. And also for 4 by 1, we do that. And then we have very simple examples where we have to take the power of 3 square minus 2 by 2 to the power 3 cube. So then we have to take a very simple exponents of 3 square and 2 minus 2 cube, and then 4 square. And then we multiply this. Then we get these exponents solved. 3 square, 2 to the power 3, and 4 square. And that comes out to be 9 minus 8 divided by 16. And then we follow the simplification of fractions, where we take the multiplicative reciprocal of 1 by 16, that is 1 by 16, and then get the final answer of 1 by 16. Let's take this new example of 5 to the power n plus 2 minus 5 to the power n plus 1, and so on. I understand there is a n value that is unknown, but we will simplify it so as to get rid of the n value, and then we can understand how to simplify this. This is a very popular question, so it's good that you understand this question. It gives a very clear understanding of how to work with exponents. So first we'll simplify this using the laws of exponents. 5 to the power n, 5 to the power into 5 to the power 2 minus 5 to the power n into 5 to the power 1, whole divided by 5 to the power n into 5 to the power 3. Then we can take 5 to the power n common in both of this in the numerator. So this comes out to be 5 to the power 2 minus 5 to the power 1, and the denominator remains the same. Then we can cancel out 5 to the power n in both numerator and denominator, and then we have 5 to the power 2 minus 5 to the power 1 divided by 5 to the power 3. And then we can easily simplify this as 25 minus 5 divided by 125, which comes out to be 4 by 25. I hope you understand this. The cancellation of 5 to the power n gives us the exact thing that we need to solve, so we don't really need to know what the value of n is. So we'll do a different kind of question now, where we have 8 to the power x, where we have have to determine 8x whole to the power x, and we have an equation 9 to the power x plus 2 is equal to 240 plus 9 to the power x. So let's first take the expression that we have, the equation that we have, and simplify this using the laws of exponent. We take 9x common, and then we have 9 square minus 1 equal to 240. So 9x 81 minus 1 is equal to 240. Then we can just simplify this 240 divided by 80, which is equal to 3. So 9 to the power x is equal to 3. We will convert the base here. So 3 to the power 2 is 9. So we convert the bases on both sides as same, and then we equate both the equation, which gives us 2x equal to 1. Therefore x is equal to 1. And as we need to find the value of 8x whole to the power x. Now as we know the value of x as 1 by 2, we have 8 into 1 by 2, 1 by 2 whole to the power 1 by 2. So we have, if we simplify, 4 to the power 1 by 2, and then if we convert this 4 to 2 to the power 2 into 1 divided by 2, we get 2 to the power 1, and the final answer comes out to be 2. So 8x whole to the power x is equal to 2. I hope you understand this. I understand this is a comparatively difficult question. I hope this makes it a lot clearer. And now this is the end of our exponents chapter. We will move on to the squares and square root chapter in the next section. If you like more content like this, please subscribe to our channel.